The seventh question that we have is a very important and a very conceptual problem. We have been given a string whose mass and length is given and it is under tension, and we have a pipe which is closed at one end and is 40 centimeters long. Now it is given that when string is vibrating in its first overtone and the air is vibrating in its fundamental mode, then 8 beats per second are heard. Now it is also given that decreasing tension in the string decreases the beat frequency. The velocity of sound is given and we need to find out the tension in string. So let us first analyze the first data. It is given that the string is vibrating in its first overtone. Now we know that first overtone is equal to 2V upon 2L, because V upon 2L is the fundamental mode frequency. The next frequency is the first overtone, that is 2V upon 2L. This is also known as the second harmonic, or twice the multiple of V by 2L. Second harmonic and first overtone. Be careful over here. First overtone is not V upon 2L. First overtone is 2V upon 2L. Therefore, the string is vibrating in its first overtone. Therefore, V upon L is its, V is the velocity of transverse wave in the string, that is equal to root over T upon mu, that is mass per unit length, into 1 upon L. Now this is the frequency of the string. Let this be F1. Now for the second one which is given, we have a pipe which is closed at one end. It is vibrating in its fundamental mode. So in its fundamental mode, we know that the frequency is Vs upon 4L, where Vs is the speed of sound and L is the length of the tube. This is coming out to be equal to 320 upon 4 into 40 centimeters, that is 40 upon 100. This comes out to be equal to 200. This comes out to be equal to 200 Hertz. Therefore, we know that frequency F2 is equal to 200 Hertz. Now, be very careful over here. It is given that beat frequency is 8 beats per second. Now, beat frequency is modulus of F1 minus F2. It is not F1 minus F2, it is modulus of F1 minus F2. Therefore, we know that modulus of F1 minus 200 is equal to 8. This is the information we have. Now, F1 can be either 192 or it can be 208. But we have an extra information given over here, that decreasing the tension in the string decreases the beat frequency. Now suppose we assume that F1 is equal to 192. Now if the tension in the string would have been decreased, then this quantity would have decreased, because tension would have decreased, all the other things are constant. Therefore the frequency would have decreased. Therefore it would have been something like 191 or 190. Then the beat frequency would have increased, because F1 was already less than 200, it has become more less than 200, that is 190 or 191, therefore the beat frequency would have increased. But since the beat frequency is decreasing, therefore this frequency would have been initially 208. So that when this frequency decreases on decreasing the tension, the beat frequency decreases. Suppose this decreases from 208 to 206, then the beat frequency will decrease. But if it would have decreased from 192 to 190, the beat frequency would have increased. So this information given to us is very, very important and it is not a waste. Therefore this helps us to find out that frequency of the vibrating string is 208 Hertz. So now that we know the frequency of the vibrating string, we put it over here to get 208 is equal to root over T upon mu is mass per unit length, M upon root L upon L, that is equal to M into L. Therefore this is equal to 208. On solving this we get 208 is equal to root over T upon mass is given to be 2.5 grams into 1000. The length is given 25 centimeters, that is 25 into 100. We multiply numerator denominator by 10. We get 25 over here. So we get 208 is equal to root over T upon into 1000 divided by 25, that is 40. That is root T is equal to 208 upon 40, that is equal to 5.2. Therefore T is equal to 5.2 whole square, which comes out to be equal to 27.04 newtons. So a final answer for the tension in the string comes out to be equal to 27.04 newtons. So the important things we learned from this question was that what is the meaning of overtone and the fundamental mode, and that beat frequency, the formula for beat frequency is modulus of f1 minus f2. If you forget the modulus, you may get the wrong answer. So final answer comes out to be equal to 27.04 newtons.